In order to find the equation of a line given 2 points, you need two things. You need a point. Well, no problem there because we have two of them. And you also need the slope. With those two things, you can make the equation of this line. Now, actually, if they had given you the slope in 1 point, we'd kind of be a step ahead. If you can take 2 points and find the equation of a line, you can easily find the equation of a line given 1 point and the slope. Well, our first job is going to be to find the slope, and I have a video on finding the slope from 2 points. I'm not going to cover that here. I'm just going to do it. I strongly urge you to stop here and see my video on finding the slope of a line given 2 points, and then come back. Otherwise, some things might not completely make sense. So first, let's talk about the template that that we have for our linear equation. There's a couple of them actually. The one I'm not going to use here, I'll put over here, y equals mx plus b. You could use this, but I have another one that I prefer. Although I think at the end of this video, I'm going to do the same technique using this just so I cover both techniques. You might like that one better. But the formula, our template that we're going to use to find the equation of a line given 2 points comes from what I do in that other video, and that's simply this formula that you may have seen before. 1y minus the other over 1x minus the other. This is actually our template. This is the equation of a line because a line is defined by its slope, and m is the slope. It's the ratio of a change in y over a change in x. So, but now I'm gonna move things around and get it into a little different form. First thing I'm gonna do is I'm gonna take the subscripts off the first x and the first y. The reason for that is when we make an equation, so like just a typical equation, well, there's going to be a generic y and a generic x. That stands for any x-y pair that makes this true. Well, so when you have a subscript, and I talked about those in the other video, it's where you plug in a specific value. Whenever you see a subscript on a variable, we're pretending that we have plugged in a specific value for those. They're not just wide open and generic anymore. Well, I already know that my equation needs to have a generic x and a generic y in it. And so this is like a specific y and a specific x point, and this is any xy point that exist. And so I'm going to take this and rearrange it. So the first thing I'm going to do is I'm going to multiply both sides by this denominator. So which means I have to multiply this side. I can always multiply both sides by anything I want. And this cancels and it just leaves y minus y2. That 2 doesn't really matter. It's just generic y minus a specific y. And over here, one thing I'm going to do, I'm going to switch the order of the m and the parenthesis, because that doesn't matter. 2 minus 3 is the same as 3. Sorry, 2 times 3 is the same as 3 times 2. So this is multiplication. It doesn't matter if I switch the order. And the only other thing I'm going to do is, and let me get a different color, I'm going to switch the sides here, because normally when you see this format, it is the y stuff is on the left and x stuff is on the right. Okay, now this form here is another version of this. This is like a standard template of a linear equation. This is also a standard template of a linear equation. They both do the same thing, pretty much, so, well, this is the one I'm going to concentrate on. But like I said, I'll use this one time at the end just so you see that technique as well. Well, what we're going to do is we're going to take this formula and we're just going to fill it in. And we're going to have our equation. So how do we fill it in? Well, first step is I've got to find the slope. I need a point, but I have two of those. Either one of those will work, but I just need the slope. So step one, find the slope. Well, the slope is going to be, I'm looking at these 2 points, and I can either subtract left minus right or right minus left. I'm going to do left minus right. So left y minus right y, left x minus right x. That gives me 2 minus 0 is just 2. That gives me 9 halves. I'll write the m again over here. There's my slope. Well, I have everything I need to fill this in. I have a slope, which is m, and I have a point. I'm either going to take this point or this point, and here for the specific, the x2, y2 point here, I'm going to put those in there. And then the generic y and x, well, I'm just going to leave those alone. So basically, here's all you do. You're going to take y minus, you're going to put your slope, x minus, and then this x2, y2 point, I can either use this one or this one. So pick whichever one you want. I think I'm going to use the left one. It will, if you use the right one, it's going to give you exactly the same equation once you clean it up. Well, this is the y part of this point is 5. The x part is 2. This is actually the equation. This is the equation we're looking for. The only thing we're going to do now is just move stuff around and clean it up. So here I have to distribute, of course. So 9 halves times x. And then I have a positive times a negative. That gives me a negative. And then 9 halves times 2 is just going to be 9. You can try it. If you, well, off to the side here. So 9 halves times 2 over 1, that would cancel. It would just leave 9. Okay, we're almost where we want to be, but normally we're supposed to have only y on the left. We want it in y equals mx plus b form. So I'm going to add 5 to both sides. And we're going to get y equals 9. Oh, that's supposed to be a 2 there. 9 halves x. 5 minus 9 is negative 4. And we're done. This is the equation of the line that runs through these 2 points. If we had used the 0, negative 4 point over here, if I had plugged that in here and here, we'd still have the same exact thing. Let's do another one. So I have my 2 points here. I want the equation of the line that runs through these 2 points, and I've rewritten our little template over here. I think I had 2 on the others. Here I have 1. It doesn't matter. It just means an xy point. This is going to be some point that that we use. Well, it can either be this one or this one. Okay, so let's fill in this template. So y minus, and I'm going to plug my point in there, but I'll wait. I am going to need my slope. To get my slope, I'll just do that real quick. I should have done that first. My slope is going to be 1y minus the other over 1x minus the other. That gives me, this is actually 5 plus 3, so 8 over negative 6, and that's going to reduce to a positive divided by a negative. 8 over 6 is 4/3. Here is my slope. That's what's going to go here. Okay, so I've just taken this and everything's filled in now except for the point that I'm going to use. So I have my slope, I have generic y and generic x. So I either need to take this point or this point. It doesn't matter. I think I'm going to take the one on the right. So the specific y I'm going to plug in for y1 is going to be -3. The specific x I'm going to plug in is going to be 4. So I have y plus 3 equals, I have a negative times a positive, 4/3 x, negative times a negative. That would be 16/3. Now I almost have y alone. I need to subtract 3 from both sides. When I subtract 3 here, there's nothing there anymore. I'm going to have -4/3 x plus 16/3, and this 3 is subtracted over here also. So I have like terms here. These are both constants that I need to combine. Well, I need like denominators. I have 16/3 minus 3. A fast way to get a same denominator, I want this to have a denominator of 3. Well, okay, just do this. Okay, so this still needs to equal 3. So I haven't changed anything. If you think about it, you'll see I haven't changed anything. I basically multiplied 3 times 1 because 3 over 3 equals 1. But now I have same denominators. So -4/3 x. Okay, so now this is just fraction addition and addition and subtraction here. First thing I'm going to do is make my fraction bar, and I know that my fraction is going to have a denominator of 3. Basically now I need to figure out the numerator. So take all your signs and put them in the numerator, not in the denominator. Well, this is 3 times 3 is 9, so I have 16 minus 9, and that's positive 7. And we are done. Let's do another one. I'm going to do it faster this time. So our slope is going to equal, so I'm going to do, I think I'll do right minus left. 4 minus 3, that's 1y minus the other, 1x minus the other, 2 minus 1. That gives us 1 over 1. So my slope is 1. Okay, well now I have everything I need. I have a slope and a point. So now I'm simply going to do y minus. My slope is going to be here. I'm going to do an x minus, and the only thing left to do is pick one of these points and stick them in. Put the y part here, x part here. So I think I'll use the first one here. So y would be 3, x would be 1. Now we just clean this up. So 1 doesn't do anything. This is just x minus 1. And now I need to add 3 to both sides. And I'm going to get y equals x. 3 minus 1 is 2. We are done. On this one, you'll notice I don't have 2 points. I have a slope and a point. So actually, most of our work is already done. If you're asked to make the equation of a line from 2 points, well, then you know that you're going to have to do some work and find the slope. But what we really wanted the whole time was the slope and 1 point. That's all we need. So since they already gave us the slope, this is easier. So I'm going to just do y minus. I'm going to put the slope and x minus, and then my point goes here and here. So the y part goes here, the x part goes here. I distribute the 3, so that's going to be 3x minus 6. Now I'm going to add 16 to both sides, and y equals 3x plus 10. And that's all there is to it. Okay, basically this video is done, but I'm going to go ahead and show the other technique just briefly because you will see it and it's good to know it's around. Otherwise, if you're happy and you don't want to know the other technique and you just want to keep what you've learned, the technique that we're doing so far, then you can turn the video off. But I put down here the same exact problem that we started with, and here's our answer. And we used this format. This was our basis. Well, now I'm going to use y equals mx plus b as our format. Well, what do we need? We need an m and a b. If I knew what m was, I could just substitute for m, and if I knew what b was, I could substitute for that, and we would be done. Well, we need the slope. This is m. And I'm going to go ahead and we already figured that out up here. So first step would have been to figure out the slope. We have that. Now I already know what m is. How can I figure out b? Well, this is where we use the assistance of one of these points, whichever one that you want. We're going to borrow it just for a minute. We're going to take one of these points and plug it in for x and y, and then with m in there, we'll be able to solve for b, and then we'll take that xy point back out, because we don't want to leave it there. We want a generic y and a generic x in our equation. So let me get a little more space here. And so what I'm going to do is write what I know m is, and here and here I'm going to plug in one of these points. So I think I'll take the 5 and the 2. And again, it wouldn't matter. You're going to end up with the same exact equation anyway. Well, so when y is 5, we know that makes x 2. And that gives us information to pin this b down. Okay, well, that's all I care about is solving for b. So 5 equals, what's 2 times 9 halves? Well, that's just 9. If you think of that as okay, 2 over 1, and 2's cancel, and it just leaves you with 9. Okay, we almost know what b is now. Well, now I'm going to subtract 9 from both sides, and we see that b equals -4. Okay, well, that's all we needed. We have all the information needed. We have m and we have b. Here's m and here's b. So now we're just going to fill it in. What's m? It's 9 halves. We're back to generic x and y now, right? We're not going to leave a point stuck in there. We pull it back out once we used it to pin b down. But now we know that b is -4. And there we go. So same answer we got with the other technique.